looking at 3-2, we have what's called the sum and difference formulas. So up until this point, if we wanted to find the exact formula or the exact angle or value of angles using our sine, cosine, tangent functions, we either use the ones that were given to us on the unit circle, which would be our 30, 45, 60, 90, and all the multiples of that, right? We could reference those, all the ones that are listed. Or the other one is we punch in the calculator, right? What we punch in the calculator is that an exact answer? No, it's an approximation. All right, an exact answer would be like the root 3 over 2, for instance, not whatever that would be if you put it in a calculator. So there's a whole bunch of other measures, though, too. All right, what about the other angle measures? So that only covers our main ones here. There's intermediate ones. There's other ones that we don't touch. What about 15 degrees? Okay, we don't know how to figure that out. The only thing we know how to do is punch in the calculator. So if we want to find the exact value of something like that, we could use something called the cosine of the difference of two angles. So what this is saying is you have two different angles and you subtract them. So you have the cosine of alpha minus beta is equal to the cosine of alpha, cosine of beta, plus the sine alpha, sine beta. You multiply the cosines, add the cosine, and add the sines then. All right, so let's look at one and see what it looks like. So I'm going to find the exact value of 15 degrees. Now, looking at the degrees that I know, 30, 45, 60, and 90, give me a combination of those angles I know. If I subtract them, I'm going to get 15. See a way I can make a combo of those? Yeah? So the cosine of 15 degrees, I don't know what I mean yet. Wouldn't that be equal to the cosine of 60 degrees minus 45 degrees? That's what I'm saying. I'm making a combo of other angles that I know. I know 40s, 45s, I know 60s, I know 30s. In this case, I did 60 minus 45, which is 15. Again, this is not going to cover every single angle, but it's going to get us closer. It's going to give us a few more to work with. All right, so the cosine of 15 degrees is equal to the cosine of 60 minus 45. Now, I'm going to apply this formula here. Okay? So when I'm subtracting the two, I have to do this difference of two angles formula for cosines. So that's going to be then the cosine of the first angle, which is 60, times the cosine of the second angle, which is 45, minus the sine of the first angle times the sine of the second angle. Okay? All I did was just rewrite this first equation to here using this formula right here. Okay? Now I have this in things that I know. All right, if you have your unit circle, to be something good, make sure you know where that unit circle is at, that you can keep referencing that. What's this cosine of 60 degrees? Good, 1/2. Cosine of 45 degrees. Good, root 2 over 2. Sine of 60 degrees. Good, root 3 over 2. You guys are remembering these so well. This is off the unit circle. And the sine of 45 degrees. Root 2 over 2. Great job, guys. Great job recalling those angles. All right, all you do is look at the unit circle for all those ones. All right, or the unit circle, or the 30, 60, 90, 45, 45, 90 triangles, those special triangle setups we had that would be in there as well. All right, so now just simplify. One on the left, I have 1 times root 2, which would be root 2. 2 times 2 is 4, minus root 3 times root 2 is root 6. 2 times 2 is 4. All right, it's common denominator on the bottom. Can I add a root 2 and a root 6 together, though? No, I can't add those. So that's just going to leave me with an answer of root 2 minus root 6 over 4. Is that an exact answer? Yeah, it is. I didn't approximate anything. I didn't turn anything to a decimal, nothing like that. So I was able just to manipulate using that. questions so far? Nobody? All right, let's try. Nah, we'll just go. All right, that's pretty straightforward. Now, then you might have one that looks like this. Find the exact value of the cosine of 80 degrees, cosine of 20 degrees, plus sine of 80, sine of 20. That is just the reverse of what we did on the last one, isn't it? Okay, so now we can use that formula, go backwards. We rewrite this as, what's 80 and 20? Well, I made a mistake up here too, anyhow. That should be plus down through. Sorry. Okay? That should be pluses. But it's for the difference angle, right? So this is all equal to the cosine of 80 minus 20, right? Based on our formula. Cosine of the first, cosine of the second, plus sine of the first, sine of the second. All right? So this is 80 minus 20, which is what? 60. That's cosine of 60 degrees. Do I know how to find the cosine of 60 degrees? Absolutely, on the unit circle. What's cosine of 60 degrees on the unit circle? 1/2. There we go. Nice job. All right, so we just use that formula in two directions. Okay. What do you mean, what about the others? This side over here. I just rewrote it. Okay, look at the last one. We went from here to here. This one here, we went from here to here, essentially. Okay? Because it's cosine, cosine, sine, sine, it's the difference of cosine. You'll see, there are going to be 4 of them here in a second. You'll see where they match up together. All right, questions so far? We're just replacing, using that formula, plugging in and chugging. All right, now let's do a little one verify here. So I have the cosine of alpha minus beta over the sine of alpha cosine of beta, and I want to show that that's equal to cotangent alpha plus the tangent of beta. Oh my God. You know what? All right. So let's deal with this left side. Now, first off, the first top of the top left there, top of the left one. All right. It says cosine of alpha minus beta. Well, isn't that the first half of our formula we just talked about? Yeah, it is. All right. So let's rewrite it. Cosine alpha cosine of beta plus sine alpha sine beta all over sine alpha cosine beta. Okay, so all I did was replace the top using that. Now that's a formula you can use for individual angles. It's also now another identity you could use. That's a alpha on the bottom. Is that what you're asking about? All right, so then back to our rules that we're looking at for verifying. If I have a big fraction, probably want to do is do what? Split it. So let's split this guy. So I'm looking at cosine alpha cosine of beta over sine alpha cosine of beta plus sine alpha sine beta over sine alpha cosine beta. So I just split it. That's why I split it, because I'm going to start slashing. All right. On the left-handed one, I got cosine of beta over cosine of beta, right? Gone. Right side, I got sine alpha over sine alpha. Gone. So that's going to leave me cosine alpha over sine alpha plus sine of beta over cosine of beta. Now I only have one angle in each one of those, don't I? Sine over cosine and cosine over sine. Aren't those tangents and cotangents? Heck yeah. So if cosine over sine, is that tangent or cotangent? Cotangent. So that gives me the cotangent of alpha plus tangent of beta. Boom. There's no crying in math class, all right? Did you ever see A League of Their Own? There's no crying in baseball. There's no crying in math either. Alpha and beta, they're just Greek letters, the same as theta. You could use X and Y if you really want to. All right. So here is some more application type stuff, more just for straight angles. There'll be no, if you look on your page, look on your note sheet, does it say verify anywhere on that sheet or the next sheet? All right, so let's just do some calculations. Yeah, there's one on the back, I know. But all right, so here is our sum and difference formulas for all of them. Okay, we already knocked out number 2, the difference of the cosine formulas. But for the sum and difference, cosine, we have the sum, and then we have the difference. So just take a minute to look at these. For cosine, anytime you're dealing with cosine, it's cosine of both angles, then sine of both angles. Cosine of both, sine of both. All right? If it's a plus cosine, it's a minus over here. If it's a minus for the cosine, it's a plus over here. Okay? Just see there's a pattern with them. Now when you go sines, sine is always going to be sine, cosine, cosine, sine. Sine, cosine, cosine, sine. Okay? So you dealt with a cosine if it's cosine, cosine, sine, sine. You dealt with a sine if it's sine, cosine, sine, cosine. Okay? It's just a little bit different setup in the way that the relationships work out. All right, but that's one way to look at these. If you ever see something with a sine, cosine minus a sine, cosine, then you dealt with a sine. If you have a repeat cosine, repeat sine, you dealt with a cosine. See what I'm pointing out here? Cosine. All right. I won't do cosine, cosine. Cosine, cosine. So if it's a cosine, pair of cosines, pair of sines. If it's sine, pair of each, pair of each. Better? Yeah? Okay. Somebody's having fun. All right. We are having fun. All right. So we're going to use the sign of a sum to find an exact value. So we want to find the exact value of the sine of 7 pi over 12. Okay. 7 pi over 12. Is that going to be found on your unit circle? No, it is not. But I'm going to give you a little hint. 7 pi over 12 is equal to pi over 3 plus pi over 4. There will be hints. There will be hints a lot of times. Okay? There'll be quite often you'll have a problem like this that says find the exact value of sine 7 pi over 12, given that 7 pi over 12 is equal to pi over 3 plus pi over 4. All right? You're going to see that quite often in homeworks or on a test and that kind of stuff. All right. So looking at this then, I am going to use sine because I want the sine function. And I'm adding the two angles together, correct? If I add the two, then I'm looking at number 3 up here. You with me? Sine, addition of two angles. Common denominator. Common denominator is 12. Okay, so you'd have to multiply this one by 4 over 4. Making this 4 pi over 4. Plus the second one multiplied by 3. 3 pi over 12. There we go. 7 pi over 12. Got it? Okay. So we know then sine of 7 pi over 12 is equal to the sine of pi over 3 plus pi over 4. From there, it's plug and chug. All right? Plug and chug. I had a college professor who said that all the time. She drove me nuts. She also wore sweatpants to teach class. So, okay. So yeah, there you go. Plug and chug, guys. You know, I don't know. All right. So we plug it in. I had to deal with it, so I'm making you deal with it. All right. So sine of the first, cosine of the second. So sine of pi over 3, cosine of what? Pi over 4. Plus cosine of the first, pi over 3, and sine of the second, pi over 4. Okay? We use number 3 up there.
What do you use these for? I don't think you can find. I just don't understand why you have to write on the side.
What's that?
I don't think you can build stuff for this.
Oh, yeah. All right, so what's the sine of pi over 3? Woodron, you got the answer. What's your question? Why does the order matter?
Yeah, if you're on sine, it doesn't matter if when I put sine and cosine first.
You could put, you could flip these two because it's just addition. And you could flip either one of these because it's multiplication. All right, but if you keep the order, it's going to make it easier to memorize those, to make it quicker on yourself. You know what I mean? But yeah, the order doesn't matter. I could do cosine of pi over 4, sine of pi over 3 for the first set. It doesn't matter there. Okay? But if you think of it, sine of two angles, sine of the first, cosine of the second, cosine of the first, sine of the second. I had to memorize these at one point. All right. So, what's the sine of pi over 3 from the unit circle? Yeah, root 3 over 2. Good. How about pi over 4? Root 2 over 2. Perfect. Cosine of pi over 3. 1/2. Sine of pi over 4. Root 2 over 2. Okay? As soon as you see pi over 4 at 45 degrees, it's going to be pi over 2 for both of them. All right? What's up? All right, so let's multiply them. What's root 3 times root 2? Root 6. 2 times 2 is 4. 1 times root 2 is root 2. 2 times 2 is 4. Okay, I cannot combine the top, so I end up with root 6 plus root 2 over 4. All I just was replaced. They're not bad? All right, so here's the next one. So the next one here, I want you to find the sine of 5 pi over 12, given that 5 pi over 12 is equal to pi over 6 plus pi over 4. So it's very, very similar, isn't it? Okay. So we're going to be using the same one again, number 3. Plug it in. All right. I'm going to give you about 5 minutes to try that. So, for this one, we're going to rewrite this as, the sine of pi over 6, right? Plus pi over 4. Okay, now when I apply the formula, what do I get? Sine of, yeah? Uh-huh. Uh-huh. Okay. What is the sine of pi over 6? 1/2. Cosine of pi over 4. 2 over 2. Cosine of pi over 6. And sine of pi over 4. Okay. So from there, this simplifies on the left one to what? 2 over 4 plus root 6 over 4, which is going to be root 2 plus root 6 over 4. There we go. And yes, it did come out to be the same answer. Okay. Why? Just because it's all interrelated. All right. All right. Questions so far? I think you guys were able to navigate that one, weren't you? All right. So now we're going to do another one. Okay. Now we're going to do another one. This one is going to maybe help you see a little bit more of what this is going to be. Okay. Now, suppose that the sine of alpha is 12 over 13 for a quadrant 2 angle alpha, and sine of b is 3/5 for a quadrant 1 angle beta. Find the exact value of each of the following. So we're going to find the cosine of alpha, the cosine of beta, cosine of alpha, cosine of beta, and then the cosine of alpha plus beta, and the sine of alpha. Should say alpha, yes, sine of alpha plus beta. All right. So, first off, let's draw our triangles that we're going to use for this. Okay? So, we have our angles. First off, we have a quadrant 2 angle, right? Quadrant 2 is going to be right there. We're talking sine of alpha. So, sine of alpha would be opposite would be 12. Hypotenuse would be 13. Now, alpha would be this angle right here. Okay? The second triangle that was described to us was a quadrant 1 one, and it said it was a sine of 3 and 5. Opposite, hypotenuse, this guy here would be beta. Now, we're missing a side on both of these, aren't we? Yeah. All right, if I look over at the left-handed one, I have a 12 and 13. Well, that's part of a Pythagorean triple, isn't it? 5, 12, 13. Yeah? Now, looking at that, based on how it's constructed, is that a positive 5 or a negative 5? That'd be negative because it's in quadrant 2, and that's to the left. Okay? Now, the one on the right, I'm missing a side, but I have a 3 as a leg and 5 as a hypotenuse. That's another Pythagorean triple. What would that missing side be? 4, 3, 4, 5 triangle. Okay? And it's positive because it's to the right. All right? Oh, fun fact. I was squaring something up the other day, and I was squaring something. I was putting stakes in for the garage. All right? So I could put it down, you know. I set one corner stake, and then started to set the second one, you know, measured it out how far I wanted, and then I wanted to set the third one. Well, I needed to make sure it was square, right? So then, you know, my dad was there helping me. He pulls out his calculator. He goes, "What's that thing you got to use to make sure the hypotenuse is right?" Pythagorean theorem, right? So then he comes from that. So he does. This was not a lie. Just wait. So then he couldn't type it into his calculator right. Right? He couldn't figure it out. So then it was like 24 and 24, right? So then he tried to use the Pythagorean theorem. He gets like 24.8. I'm like, what the heck you doing? Yeah. So then he goes, well, how do I do this? Well, I said, well, at the same aspect, we got 24 and 24. So that's a 45, 45, 90 triangle. So that would be a factor of 1, 1, and root 2. He goes, huh? I said, take 24 times root 2. And it was like 33.8. Beautiful. Beautiful. I was juiced. I couldn't wait to get back and tell you guys about it. That was setting the corner pins at right angles. It wasn't. Setting the corner pins. Guaranteeing a 90-degree angle. How do you guarantee right angles? The Pythagorean theorem! Or as other people say, is check the diagonal. They're using Pythagorean theorem, they just don't know. Anyway, back to this. So I got my triangles. Okay? Now, I got my triangles. Let's start knocking these out. So, A. Why the heck? What the heck is that? What is going on here? A. Why is it moving? There we go. A. I'm looking for the cosine of alpha, or the cosine of the fish, right? The cosine of alpha. So alpha is over here in my left-handed triangle. Cosine is adjacent over hypotenuse, so it's going to be what? -5/13. Done. B. B, I'm looking for the cosine of beta. All right, cosine of beta is going to be adjacent over hypotenuse, which is what? 4/5. There we go. We've been doing this for weeks. Okay, now C, we're looking for the cosine of alpha plus beta. All right, so I want the cosine of alpha plus beta, and then I'm going to have to do the formula, right? Cosine, two cosines, two sines. Cosine alpha, cosine of beta, minus sine alpha, sine beta. Okay, that's just the formula. So from there, I have everything I need. So I just found the two cosines. I have the two sines from the original. I'll just rewrite those here. Sine of alpha is 12/13. Sine of beta is 3/5. All right, so there's all four that I'm going to need. I don't even need those triangles anymore. The original problem. Here and here. Okay? All right, so there's the four things I need. Here we go. Cosine of alpha is going to be -5/13. Cosine of beta is 4/5. Just found that one. Minus sine of alpha, 12/13. Sine of beta, 3/5. Okay, this one have a different answer. You guys complain about the same answer. All right, so from there, just simplify them. They're fractions. So on the left side, I have 5 times 4, which is 20, and that's a negative. 13 times 5 is what? 65, good. Minus 12 times 3 is 36. And 13 times 5 is 65 again. I got the same base, so I'm good to go. What's the top going to be? -56/65. There you go. Different answer for you. We still got D to do. D is, we just did it. Sine alpha plus beta. All right? Same thing again. We're using the same four things. We just have to apply them in a different order here. Okay? So now, sine of alpha plus beta is going to be sine of alpha cosine of beta plus cosine of alpha sine of beta. So, sine alpha is going to be 12/13. What's cosine of beta? 4/5 plus cosine alpha, -5/13 sine beta, 3/5. Okay, left side 12 and 4 is going to be 48 over 65. Right side is going to be negative 15 over, okay, 48 minus 15 is 33 over 65. There we go. Questions?
Okay.
Okay, we got 4 minutes. Let's knock out this last one.
Oh, come on, John.
Oh, yeah.
Come on.
I'm not saving it for one day. It's like a minute and a half.
That's why we do it for homework.
We're not Russian. We're American. We're not Russian.
I'm hungry, bro.
What? This last thing we won't use as much.
And it looks like
All right. So here we go. You have a question? What's your question? That's not a question. All right, some different formulas for tangent. So we did sine and cosine. Let's just throw this out here too. We will not use this tangent as much as sine and cosine though. But for the tangent of adding the two together, tangent alpha plus beta is going to be tangent alpha plus tangent beta over 1 minus tangent alpha tangent beta. All right, same thing. The difference of the tangent alpha minus beta equals tangent alpha minus tangent beta over 1 plus tangent alpha tangent beta. So we're going to verify one identity here. I know you believe me. You better believe me. All right. This is an easy identity. Okay. So tangent x minus 5 over 4. We want to show that's equal to tangent of x minus 1 over tangent of x plus 1. So first thing, let's go ahead and apply the formula we just talked about. All right, this is the second formula. So it'll be tangent alpha minus tangent beta over 1 plus tangent alpha tangent beta. All right. So I have tangent of x, and this is my first term, minus my second term, this is tangent pi over 4, over 1 plus tangent of the first term, tangent of the second term. Now, looking back at your unit circle, here we go. Tangent of the first minus tangent of the second over 1 plus tangent of the first time tangent of the second. Okay? So, oh, we're finishing this one. So then, over here to the side. Tangent of pi over 4 is going to be equal to what? 1. Okay. It's equal to 1. So I can go ahead and replace tangent of pi over 4 everywhere with a 1. So I have tangent of x minus 1 over 1 plus tangent of x would be times 1, right? Well, look at that. You rewrite that, puppy. You have tangent of x minus 1 over tangent of x. Hold on. Tangent of x plus 1. Guess what's the same? Boom. Done. There will be some homework. I'll see you tomorrow. I'll go back. I just stopped.